about social norm bias, residual harms of fairness-aware algorithms. This is joint work with my awesome collaborators, Adam, right there, Myra, who's right now a PhD student at Stanford and at the time was an intern at MSR, and with Lester. And this is work that we published earlier this year. So when we're talking about algorithmic group fairness, something that I don't need to mention to this group, we're measuring some form of disparity across sensitive groups on a measure of interest. And when we're applying bias mitigation approaches based on these definitions, we have different variants for these strategies. Primarily, we have pre-processing, in-processing, and post-processing. So these are all different ways of enforcing certain metrics of interest at a group level on algorithms that we're developing. And these type of group fairness approaches have been very popular in deployment because they're very easy to implement. And this is especially true for post-processing algorithms that don't require any retraining. And this has computational advantages, but it also has a lot of organizational advantages. If you're at a company and you need to change a lot of different stages of your pipeline, it's much harder than if you want to say, okay, we're gonna keep everything the same, and then we're just gonna implement a change at one stage. So the question at the center of this work is algorithmic group fairness enough? And so when we're talking about sensitive groups, when we're talking about group fairness, typically the sensitive group that we're concerned with, this actually corresponds to a social construct that is very complex and it has multiple dimensions. And we're taking kind of a reductive definition when we're saying we're going to treat this as an indicator function of, do you belong to this group or do you not belong to this group? And we're not the first ones to point this out. There is a lot of really interesting research that has pointed this out and has given us guidance of how do we reason about this, right? In philosophy of AI, there's been a lot of really interesting work on this. Lily and Isa's work has given us very strong critiques on what are the limitations when we take this type of reductive definitions. And these also relate to whether we're doing an ideal theorizing of fairness, right? So what motivated us was saying, okay, can we identify concrete harms that we're leaving out when we're taking these reductive definitions? And this is different than saying, well, is there also an individual notion of fairness that we may be concerned about? This is saying, we decided that we're concerned with fairness with respect to a certain group. This is with respect to a social construct. Are there types of harms that relate to that group in particular that we're leaving out? Are there these type of residual harms? How can we measure them? And then once we have measured them, another question that we were interested in is any algorithm that is taking these type of reductive definitions having the same type of residual harms? Or using the same reductive definition, can we actually have different types of residual harms for different types of bias mitigation approaches like the ones I mentioned at the beginning? So we're going to focus on gender today in particular. And so, as I said, when we're talking about gender, we typically say, okay, we're going to have an indicator function that we're going to use as what gender do you belong to, but this is a much more complex social construct. There's an educational toolkit called the gender bread, and so this gives us a kind of simplified representation of the multiplicity of gender, right? So what this shows us is when we're talking about gender, we're actually talking about a lot of different things. And this is not saying that we need to think about a multi-group, actually, because this is not saying, well, we're going to think about all of these as different group memberships, and then we take the indicator function and that's it, right? When we're thinking about, well, is your gender expression, is it feminine? It's not a binary. It's not that you say, well, you are feminine, you're not. It's much more complex than that, right? So this is the context. This is what I mean when I say that we're taking a reductive definition. And generally, when thinking about algorithmic harms and algorithmic injustices, I like grounding this on research that has been done on discrimination in the absence of algorithms, right? And in the context of the workplace, there's been a lot of research in organizational sciences, Madeline Hillman's work, for example, on the role of descriptive and prescriptive stereotypes in workplace discrimination. And so what descriptive stereotypes tell us is that when there are certain attributes that are, or certain behaviors that are thought of as being part of a certain identity, then adhering to those stereotypes, this is not framed, they don't necessarily frame it in terms of stereotypes, but we can think of it in terms of stereotypes. If you adhere to that type of stereotypes, then that can lead to discrimination when the membership in that group is thought of to be a poor fit for a given occupation. So let's say in many of the women in CS workshops that you go to, they tell you, well, whatever you do, don't bring cupcakes to the office, right? And it's similar to the decision, well, should I have worn a dress today to give this talk? So that is what it means to have descriptive stereotypes that are operationalized towards discrimination. And just as an aside, there's also prescriptive stereotypes. So it doesn't mean that if you adhere to the norms of the majority, then you're okay, because if you deviate from certain behaviors that are thought of that you ought to follow, then that can also be a problem. Like if you're too voluble, then you may be bossy and things like that. So, but what we're concerned with here is just descriptive stereotypes, right? So we're thinking about descriptive stereotypes. There's a lot of research in organizational sciences that have talked about this. And so the question is, do algorithms exhibit this? And are we mitigating them when we apply bias mitigation approaches based on the notions of group membership that we use? And so to do this, we define what we term social norm bias, that are the associations between an algorithm's predictions and conformity to social norms. And so some of the concrete questions that we ask here are, do algorithms exhibit social norm bias? Is this bias mitigated by group fairness approaches? And so in other words, if, for example, there's an algorithm, a bias mitigation approach that is being applied to something that I am being subjected to, can I benefit from that bias mitigation approach more if I sound or act more like a man, right? And the experiments that we'll be doing will be grounded on the bias in bios task and data set that we collected a few years ago, where the task was, can we predict someone's occupation from their online biography? And so thinking about the role of algorithms in the workplace and algorithms for recruiting and hiring, the simplest task that an algorithm can solve is, what is your occupation? If I'm gonna use your website to decide whether I target you with an advertisement for a job, can I tell which job should I be targeting you with? And so this is an example. This is when we did this earlier research on bias in bios. This was my biography at the time. And so here, for example, it would predict that I'm a teacher, right? And so this data set has approximately 400,000 online biographies. And it is collected in a way that we know what the occupation is from the 28 possible occupations from the Bureau of Labor Statistics, which are very varied. It ranges from professor, it's actually the most common one, which shows you both that us professors really like having our biographies online, and also the fact that maybe the regular expression that we used to collect biographies was a better fit for the way that we write our biographies. And we also have other occupations like yoga instructor, physician, surgeon, and so on. So this is the example that will anchor things in, but before that, I'm going to move to how do we measure the inferred social norms? So we have, by the way, any questions so far about any of? Okay. So we can delve into measuring inferred social norms. So as I said, we care about social norm bias. And so the first question is, what are the social norms that the algorithm may be inferring? And so to do this, we estimate, we build a predictive model that estimates the probability that you belong to a certain group. And so we have a prediction of how likely you are to belong to a certain group. And then once we have this prediction, in the case where the class that we're predicting is binary, then we can take a set that is for a given group, for the individuals in a given group and belonging to a certain class. Then what is the prediction that we're obtaining for the main task that we have? Let's say predicting someone's occupation. So we have 4 individuals, for women who are surgeons. What is the predicted probability that we have that they're surgeons? And then we also have a set, we have the set of the predicted probabilities that they are, so this is based on the pronouns. And as an aside, the original data that I showed you had only binary pronouns. In this second, in this follow-up, we did an additional analysis where we did some manual assessment of biographies that were used they as a pronoun, and we manually verified that they were referring to an individual and not to a group. So we extended it to non-binary pronouns, but I'll be primarily focusing on the results for women here. And so we have these 2 sets, and then here we can measure the correlation between these 2 sets of predictions. What is it that this correlation tells us? What this allows us to answer is whether the predictions of a central task that we're concerned with, such as predicting someone's occupation, correlate with inferred social norms. The inferred social norms are norms that can be inferred from the data set that is being used to train a model. And so in the context of predicting occupations, for instance, what this tells us is whether the likelihood of correctly predicting someone to be in their occupation is correlated with how feminine or masculine they can be inferred to be based on the data set of biographies. We can also extend this to the multi-class setting where we have more than 2 classes, and this is something that is necessary for the task that we're focused on here, where we have 28 classes, right? And so what we have here is we get an added step. So we have the same 2 sets, right? Now we just have a subindex here because we have a given class. We have the correlation between these 2, and then we have a set of correlations, right? So this is for women in each occupation. What is the correlation between how likely they are to be perceived as feminine or masculine, right? And then how likely they are to be predicted to be in that occupation. And then we also have the fraction of the data in this class group set. And so there, what we can do is we can measure the correlation between these 2, okay? So the first question to ask is, well, I've been talking about inferred social norms. Is there any relevance to the inferred social norms? They don't need to be corresponding to social norms. And so if I were to infer social norms that have nothing to do with the way that society is structured, then maybe that wouldn't be harmful. I'm just correlated with some random thing that I learned specific to this data set that is not really at risk of compounding any harm, right? So the first thing that we do with this data set is look at what is it that the algorithm is inferring as its social norms. So to do this, we have the algorithms, and so we have weights for each word. So here we're just looking at a representation of the word. In this case, this was weights for the word embedding. And so here we're looking, and here this is the genderedness for human labeled words. So this is from this work where they did an annotation experiment where people said, okay, how gendered is this word, right? So what we see is that there's a very strong correlation between these 2. So the norms that the algorithm is learning are very correlated with existing social norms. The reason why then this matters is because if the algorithm then is making predictions that are correlated with these social norms, then it means that we are at risk of compounding certain harms, right? And it's interesting to see like some of the anomalies here. So for instance, this is child here, which naturally the word child itself is not a very gendered word. But in the context of biographies, it turns out that women are much more likely to mention their child in their biographies. And so it is gendered in what the algorithm infers to be social norms in the data set of biographies. So, yes.
These word embeddings are coming from bios.
From bios, in bios, yeah, from bios. Yeah, so what we have in the y-axis here is from our data set, what we learned, right? And so we're saying, okay, in predicting that someone belongs to this group, right? What is it, how much weight is it giving to each word, right? So what we're seeing here is words that are higher up are words that the algorithm infers to be more masculine, so more predictive of you're likely to be using male gender pronouns in your biography. And at the bottom of the y-axis are words that means that the algorithm is going to be more likely to predict that you're using she as your pronouns in your biography. In the x-axis, this is a separate data set that was human labeled. And so this is what humans perceive to be, like how gendered humans perceive to be these words to be. So basically we take the subsets of all the data set of all the words that were labeled in this human annotation. And that's what we're seeing in the dots. And then we take from all of those words, which are the ones that appear in the bios, which most of them do because the data set is pretty big. And that's what we're visualizing here. And so here we know that the inferred social norms have some meaning. And then there's a risk that if we're making predictions that correlate with this, then there could be certain harms. But are we making predictions that correlate with this? So this is what we look at here. So here we're seeing the percentage of biographies in the occupation that use she as the pronoun. And so that's what we're seeing in the x-axis. In the y-axis, what we're seeing is the correlation that I described before. So the correlation between the likelihood that you'll be predicted to be in a certain group and the likelihood that you will be correctly predicted in your occupation. An important thing to remember is that this is just for the subset of people that are in that group, in that occupation, right? So if there was no correlation, we should be seeing things lying on a horizontal line here. What we see is very different. We see that there's a correlation here. So this is the measure that I mentioned for the multi-class measurement. And so what we see is that the strength of the correlation increases with the occupation's gender imbalance. And what the direction of that correlation is determined by what is the predominant group in that occupation, right? And so what this means is that how likely I am to predict that you're a surgeon is correlated with how masculine do I perceive your biography to be. So an example of social norm bias in the context of algorithms would be the word empowerment is a word that the algorithm associates to inferred feminine social norms. And so if a woman surgeon uses the word empowerment in her biography, then the algorithm is less likely to classify her as a surgeon. So now the question is this something that we're mitigating when we're using bias mitigation approaches that operate at the group level? So we compare multiple bias mitigation approaches ranging from pre-processing, multiple in-processing approaches, and post-processing approaches. All of the ones that we're plotting here are, operate at the group level. We also played around with Cockle, for example, which is an approach that we proposed a couple of years ago that doesn't directly use the groups. And so what we're seeing here is the same plot that I just showed you, right? So basically, the less correlation that we have here, the better, right? We want these things to be flat. And so there's a number of things that we see in these results. The first is that these type of gender correlations can persist even when we're using fair-aware interventions, right? So the fact that we're mitigating things at the group level doesn't mean that we're mitigating this type of bias. But the different approaches are very, very different from each other. And there's a number of things that are worth noting here. The first one is that post-processing doesn't mitigate this type of bias at all. So I don't have here plotted the initial approach, but it's because it's exactly overlaying with post-processing, which makes sense, right? In post-processing, the whole point is that we're not changing the within group ordering. And what we're measuring here is directly deriving from within group ordering. So the issue that is happening here is if we first learned a classifier that has social norm bias, meaning your likelihood to belong to a certain class is dependent on how much you're adhering or deviating from social norms of the majority group in that class, then post-processing is not going to fix that at all. The other thing that we see is that other approaches do mitigate it, some of them quite a bit. But it's not something that follows. This is something that, again, is intuitive, because if what we're saying is, for instance, with an in-processing approach, we're saying I'm going to penalize you if you make a prediction that results in certain types of errors, then I'm nudging you to use another signal. And so that different signal that you're using for prediction may yield better results in terms of social norm bias. The key there being the element may.
So we're doing something beyond and you had one of the group definitions correspond to the perceived social norm. Post-processing in this case,
so the challenge there would be, how do you define the multiple dimensions of the construct as multigroups, right? Because if you're thinking about feminine or masculine, it's much more of a spectrum than whether you're feminine or masculine.
But you managed to do it recently here, right? You do have a definition of perceived social norms. So I'm saying the same.
If you directly penalize for that correlation, you mean?
Yeah, if one of the definitions of the groups corresponds to the way that you specifically define perceived social norms, and many other potential, like you can the idea of multigroup, you can do it for 1,000 groups or more.
Yeah, so there's two parts to that. So part of it, I think the answer is potentially yes. There's a number of risks there. And so if we look at what we're doing here, right? So what we're saying is, well, we could directly penalize this correlation, right? Because so the question of, well, can we just split? There's a number of things that we could think about doing here. One is just, well, let's split our notion of gender into multiple groups and then let that be a thing. That is pretty challenging because it's not very easy for you to say, okay, for this biography, do I place them as feminine, as like, right? So that definition of the group itself would be challenging. The other thing that you're saying is, well, you don't need to define that group, right? You can just directly penalize for this measure, if I'm understanding correctly.
What I'm saying is that you can define the group not once, but 1,000 times, and make sure that whatever notion of fairness you want applies to these 1,000 groups, not one of them captures the perceived social norms, and you would not see this kind of.
Yeah, and I think that one thing that you could do there is doing those 1,000 groups, for example, like here, what we're doing is we have a prediction for whether you belong to a certain, to that group. One of the issues if you were to just penalize for this one correlation is that obviously you can have a different model that you may be just predicting like penalizing for certain type of signals. So if you were to do it with a bunch of different predictors, right? And so you could think of it as a predictive multiplicity setting in which you say, well, we're going to take a set of predictors of belonging to this group, and then we're going to define all of our groups based on that set of predictors. Then I think that it would be probably like the most direct way of penalizing this. I agree. Yeah, that's a very cool idea. And so here we see, okay, post-processing doesn't mitigate it at all. In-processing can mitigate it, but it is not a given, right? We really do need to measure these explicitly. And so to summarize, there's a number of things that we have shown in this research. First, we've shown that algorithms may display social norm bias. And so this is the type of bias that we should be concerned about. And one of the advantages that we see here is that this is giving us a very concrete way of measuring and characterizing one of the residual harms. This is not the only one, but one of the residual harms when we consider reductive definitions of social constructs. And then we see that post-processing, well, it is really, really popular. And often we think about, well, as long as we're penalizing the measure of interest to the same degree, we can just choose whichever. Why would we choose in-processing? Why would we choose post-processing? Let's do the one that is easiest. This is giving us a clear differentiating factor between the different approaches. And in many cases, a clear justification for why we may actually want to incur in the cost of retraining. And finally, we see that group fairness approaches may veil certain harms. And hopefully here we have one approach to measure one of those harms. And I can imagine future work looking at what are other types of these residual harms. And exactly as you were saying, what are ways in which we can improve our bias mitigation approaches? One of the good things here is that we see that once we measure these, sometimes we actually do pretty well, even when we're starting off from a reductive definition of fairness of the group membership. And with these, I'll pause here and take any remaining questions. Thank you, everyone.
So in your general word, I noticed the word logical that was prescribed as like, I think, very manly. And what I was wondering is, I mean, maybe some patients, you might want the word logical in your, so like requiring decorrelation in this case maybe would harm your predictor.
I love this question because this allows me to talk about something that I left out of the talk because I didn't want to pack too much. But yes, that is a really important question. That is, if the word engineer is perceived as masculine, well, I still want to use the word engineer to predict that you're most likely an engineer. And so we did a second variant where we looked at task relevant and task irrelevant words. And then we did the same approach on those. And so we had a way of looking at basically what are words that are predictive of the occupation across the different genders. And then what are words that are not predictive of the occupation, and then taking just the set of task irrelevant words, and then building G here based on just the task irrelevant words. And so here you could have the representation X that you're using being a subset of your original X, so that you're excluding the task relevant features. That's a great question. Yeah.
Obviously, for this setting, it seems very inappropriate to respect this type of group ordering. Do you think there's like realistic fairness settings where that type of group ordering might be desirable? Like if the bias is sort of, I'm thinking of this paper by John Feinberg, where they're saying like the bias affects the group uniformly, so you want to respect the group ordering. Again, not this setting, but do you think those are realistic settings?
I think that the question is, what is it? So I don't want to say no, there are no cases where you want to respect the group ordering, but the question is, what is it that is being captured in your group ordering, right? Yeah. And so whenever the issue that we're having is that we have a bias through correlated features with your group membership, then the likelihood that your group ordering is perfect is, I think, something that we ought to question a lot more than we usually do, because we usually say, okay, it's just at the group level that we have an issue, but within each group, we bet that the predictive relationships that we're using are the ones that we care about. And so I think that this hopefully shows, okay, what is the type of predictive relationship that I'm using that leads me to have a group ordering that I don't want to have.
Thank you.
Let's take the rest of the discussions offline.